All right, so I want to talk in the next approximately 20 minutes about the field level communications initiative. So I want to introduce you to the overall goal, and then talk also about the technical concept and the status and the roadmap. I want to start with this slide, which shows some impressions of the, let's say, famous press conference back in November 2018. That was when we launched the FLC initiative. The big interest was mainly due to two reasons. First reason, OPC Foundation announced to bring OPC UA to the field level. And second, this initiative is getting strong support from all the major automation suppliers in the market. So the steering committee that we have for FLC consists of overall 26 companies. So you see here the logos. It's a mixture of automation suppliers and technology providers. And these companies pay additional budget and provide resources and expertise to make FLC a success. Now, what does FLC contribute to the OPC UA ecosystem? You can see here several use cases that OPC UA is already covering today. This is here the numbers 1 to 4. So what FLC is adding to that is the controller-to-controller use case, number 5, which is the connection between different controllers of different manufacturers. And then it includes the use case controller to field device. This is then completing the vertical integration, linking controllers to the different periphery, all the different types of devices you need for specific applications in factory automation and process automation. So these devices typically are servo drives, frequency converters, IOs, sensors or vision systems or safety components. I want to emphasize that FLC is designing the concept in a way that it is easily to be adopted and extended to other technologies and future trends. So this is why we explicitly mention here the wireless integration. This is a very interesting addition to FLC, especially 5G or Wi-Fi 6, to mention just the two important standards being developed now. The overall vision is to support an open unified standards-based IIoT communication solution, which is OPC UA, to cover all the requirements out of industrial automation, to then be able to use OPC UA completely from sensor actors up to the cloud, and also vice versa. When we talk about the technical concepts, we typically make use of a more abstract model. This is what we call the interaction model. And you see here that in scope of FLC are the interactions that are in blue color. So it is including the controller to controller use case, the controller to device, which is also including device to device. But then very important, we also deal with bringing up the information from the controllers and devices up to the compute systems. So compute stands for gateway, edge, gateway, software, and even for cloud. What I want to emphasize is we in FLC are not dealing with the compute to compute interaction by itself. This is already covered by OPC UA today. but we are certainly providing additional value to that because we bring up all that process and production related information from the field up to even to the cloud. A few words about the organizational structure. So FLC is an embedded initiative in the structure of OPC Foundation. So it's aligning with the different committees like the Technical Control Board, Marketing Control Board, Board of Directors, but then is managing and is responsible for the technical work, the marketing related work, and finally the testing labs to ensure a high level of compatibility and interoperability. Now diving into the technical working groups that we have set up to develop FLC. You can see here in the red box the different working groups that we have established. So on top you find the working group architecture. This is, so to say, the umbrella for all the different subgroups that work on specific topics. We have 3 working groups working on information modeling, connecting devices, offline engineering, that are part of what we name infrastructure. So these are the basic concepts. And then we have specific working groups that work on specific topics, for example, safety, working on a functional safety solution, a motion group working on a so-called motion facet. We will start next week a prototyping working group that is verifying the specifications. And we will very soon also start with a test development group in order to define and then create the tests for FLC devices. You see also with the dotted lines that we have a lot of links to other working groups inside the OPC Foundation, and this is because we are relying on existing OPC UA technology. It's, I think, interesting to see who is actually chairing the different groups. So I'm not taking the time now to introduce all the names to you. I think key message here is that you see from the names and the companies they work for that we have a very good coverage with regard to renowned automation suppliers out of factory automation and process automation to ensure that the solution we create is balanced and supported all over the world in all the different disciplines. Now, the probably most important graphic in my presentation is the one I'm now showing you. It's an animated one because then you understand a little bit how all the different components are linked together, how they are building upon each other. So first of all, as I said, FLC is being based on existing OPC UA technology. So OPC UA with the information modeling, with the services, client server and PubSub. Very important, the integrated security. And then we are using the DI specification to build upon the extensions for FLC. The base concepts for FLC include the so-called base model for an automation component. This is a basic model of a controller or a field device, including things like state machine, basic diagnostics. And then we also add to that possibilities for offline configuration, where we have a description, a configuration of a device or a controller to be also able to do offline engineering. And then you see here the box with communication. This is what we name the communication facet. This includes mechanisms for connection management, for bootstrapping, everything you need to deploy devices or a system for a certain application. On top of that base model for the automation component, we have then the specific facets for the different device types. So this is where you find a safety facet, you find a motion facet, facet for remote IOs. We also plan to soon start a specific activity to create a facet for instrumentation. And this is then open also to other facets that we need to cover all the different types of devices, the full range for PA and FA. Interesting is also when we look to the lower layers. This is where we have a clear commitment to IEC IEEE standards. So there is certainly very important Ethernet, IEEE 802.3 with the MAC and the PHY. But I want to certainly also not forget and clearly mention the TSN, the deterministic Ethernet IEEE 802.1 with the addition of the TSN IA profile out of IEC IEEE 6802, which is allowing us to use a network in a converged way. That means you can mix traffic of different devices, different applications, even of different industrial protocols, without violating the specific requirements for the applications you run in the network. An important part of the overall approach is to use a so-called quality of service modeling. So we are describing certain QoS requirements for the application, which is then mapped to specific QoS features of the underlying networks. For FLC, we have agreed to support two different communication profiles. So there is one profile using IP best effort via UDP, typically on a conventional Ethernet. And then we have also for higher performance and for absolutely deterministic communication, a direct layer 2 mapping, which can then be combined with also the front end single pair Ethernet APL needed for bringing OPC UA into the field for applications in FA and PA. What I also already mentioned is that we are also easily adaptable to other communication standards. In this case, you just do a different mapping, for example, 5G, Wi-Fi 6. So this is all extendable. Important is also you can combine, this is now the gray box that you see on top. We can integrate companion specifications coming out of UMATI, for example, or PADIM is another good example. So that can be added to the other base device models that FLC defines. And finally, we have conformance testing to make sure the combination of the different facets and feature sets is then reliably tested and certified. Okay, talking a little bit about the roadmap, we have agreed to, in a first step, create a specification version 1, which covers the controller to controller use case, the number 5. And this is where we have in the next presentation further details about this use case and the technical concept behind. And then in a second step, we then bring these concepts to cover also the controller to field device communication, C2D, what is the short name for that. On the next 2 slides, you see further details on what are the elements of the different specification versions. So I'm not going into details because of time constraints, but you can see that we are using a first set of features in the first version of the spec and then extend this to cover additional requirements for C2D in the next step. The plan is to have a first release for the specification version 1 later this year. So there will be first drafts for prototyping available in the next weeks. And then we have to make sure then that by end of the year, when we plan to publish, that all is stable and verified. The expectation is also that for approximately 1 year later, there will be then the specification version 2 for covering C to D as well. But this has to be still to be defined. Okay, what is now the impact of the FLC initiative? And you see on this slide what we are, let's say, adding to the world of industrial automation. First, we allow that controllers of different manufacturers using different field buses or different real-time Ethernet technologies have cross-vendor interoperability. So this is the, let's say, the horizontal integration, and it's adding then to the existing link from controllers up to the edge, to the cloud. But then with the C2D, we move further down to cover also the communication to field devices, and then we have, let's say, a consistent way of communicating back and forth horizontally, vertically, to distribute the information that we get out of the process, out of the production. To conclude my speech, I put one slide out of a publication of the Industry 4.0 initiative. And to summarize the impact of FLC, you can see that with FLC, we are really making it possible to have a consistent IIoT communication solution, which is going from sensor actor up to the cloud and vice versa. And by combining OPC way with the extensions of FLC and Ethernet APL, Ethernet TSN, and in future other upcoming standards, we have a future-proof solution covering all requirements of industrial automation. With that, I would like to finish. If you have further questions, please use the chat functions, or you can also directly contact me using my email address. And with that, I thank you very much